Exactly. Yeah. Very good. That's very good. Yeah. I love to. I have your email. I'll connect with you offline. So
That'll be great.
yeah,
Awesome. I think we can get started.
sure.
Hello, everyone. Thank you so much for joining DataCon LA 2020. Welcome to the data engineering track. And soon we'll be listening to the session Forget Becoming a Data Scientist, Become a Machine Learning Engineer instead with Sujee Maniyam. I am Nilesh Tiloda, your host, and our co-host today is Cassidy Liu. We will be moderating the chat and Q&A for you during this session. Our guest, Sujee Maniyam, will be talking about forget becoming a data scientist, become a machine learning engineer instead. A quick bio about Sujee. He is a seasoned practitioner and founder of Elephant Scale. He teaches and consults in AI, machine learning, deep learning, big data, Hadoop, Spark, NoSQL, and cloud technologies. He is an open source contributor, author of Hadoop Illuminated and Edge-based design patterns, and a speaker at conferences. He also advises and mentors various companies and organizations. So without further ado, I'll hand this over to Suji. Thanks for being here, Suji.
Thank you, Nilesh. Thank you, Cassidy. Hello, everyone. Welcome. Um, and thanks for the very kind introduction. Just making sure you guys can all hear me okay. Yep. My name is Sujee Maniyam. Very quickly, my background is uh, is teaching and consulting in AI, big data, and cloud technologies. I'm a founder at Elephant Scale. In my free time, sorry, my screen just went blank. Give me 1 second. Yeah. So in my free time, I like to publish books and tutorials. And the latest one I'm working on is called guided machine learning. It's how you learn machine learning on your own. Right? So, and my contacts are here. Again, you can see the slides. You can share the slides. Sorry, I'm going to share the slides with you guys in a second. I live in San Jose, California, and as you can see, this is our cat. And you will see quite a few pictures of him in the slide. So, all right, with that, let's get started. So what is this talk about? This talk, I'm going to talk about something called machine learning engineering. And I have a Google Doc set up with you guys for some extra information. So here's a URL. If you guys are interested, just check it out. It's basically some pointers that's relevant to us. And I was kind of glad to hear, I'm glad to sort of get this MLeng URL from tinyurl. It's pretty simple, right? tinyurl.com/MLeng. And just a one pager with some links. And I uploaded the slides for you guys here. You can download the slides. And also here's the link for the guided machine learning I'm running. If you're interested, check it out. And also we meet weekly basis. So you can sign up for the weekly meetings as well. And more relevant to this talk, I'm also going to be doing a machine learning engineering class soon. So the first batch probably will be a free one online. So you can sign up here if you're interested, and I will definitely let you guys know when the class is up and running. Right, that's it. So again, just a link for you guys, tinyurl.mlh with slides and some extra information. Yeah. So let's get going. So let's start with what is machine learning and what is machine learning engineering. And if you guys know a little bit about machine learning, the definition of machine learning is computers learning to do things without being explicitly programmed. That's interesting, right? Because most of us are programmers, we write code. So when we write code, we are basically giving instructions to the computer. So how can the computer learn to do things without being programmed? Let me give you an example here. So here, let's say I'm trying to detect if an email is spam or not, right? So here's some code I'm writing, as you can see at the bottom. So I'm saying, if the email came from one of these IP addresses, then it's not spam. Or the email contains some of these spammy content, then we say spam. So as you can imagine, I'm writing these rules, and these rules can range from hundreds or even thousands. And as the number of rules really increase, it really becomes really hard to keep track of the rules. So how do we do this in machine learning, right? So here's how the machine learning approach would look like. So what I'm saying is I'm not writing any program. So what I'm doing is I'm actually showing sample data for the algorithm. So here's an algorithm. So I'm showing a bunch of spam emails. And I'm also showing a bunch of good emails. So kind of like sample email. Right? So imagine I'm sort of doing Legos to demonstrate, right? So let's say this red one is spam, yellow one is not spam. So I'm showing a bunch of emails. I'm saying this is spam, this is not spam. Spam, not spam, right? So I'm not writing rules, but I'm actually showing sample data. Now the algorithm learns from the sample data and figures out patterns. And once the algorithm has learned enough, you can show a new email to the algorithm and the algorithm will say, yeah, this is spam or this is not spam. So you can sort of see what's going on, right? So we're not writing code anymore. We're actually training algorithms. And we are training algorithms with data, right, of what we want to do. So in this case, could be email. Let's say you want to do credit card fraud. You will be training this with the data from credit card transactions, things like that. So this is what's machine learning, and this is why I always recommend software engineers learn machine learning, because a lot of this code we are going to be writing in the future is going to be like this, right? Mostly training algorithms. Okay? So hopefully that made sense. Now, so how do we do this, right? So the way it's done is, so it's called building a model. Basically what we do is we prep the data, because as you can see, right, we need data to train our model. So we need this data. So we need to prep the data, and then we train our model, and then we test our model to see if the model is doing well. If we're happy with the model, that's great. The model is ready to go. If not, we go back and repeat the process, right? So this is called model building. And a lot of the data scientists end up doing, this is what they end up doing, right? Now, where the machine learning engineer comes into the picture? Let me show you guys, right? So imagine I have the model ready, and this model is ready to go in production. So what does it take to take this model into production? And here's a little flow chart, right? So as you can see, the actual model building, which is sort of the green boxes I just showed you guys, it's just a small portion for the whole thing, right? So here I'm showing you, for example, right? I want to train models on a large scale with lots of data, right? So that's probably done in the cloud. And once the model is ready, we are deploying. So probably also done in the cloud. And we are basically monitoring the model to see how well the model is doing, what's the response times and other important metrics. And once the model is deployed, also I need a way to kind of quickly update the model to a new version. So let's say we are running model version 8 right now. We want to deploy version 8.1. How do you deploy the version? How do you upgrade the version, right? All this, so all this square right here comes into what we call machine learning engineering. Does that make sense, guys? Yeah. So hopefully, and that's where, and we always emphasize building the model is just the first step. There's a whole lot more to take the model to production. Right. So don't take my word here for me. And here's the Google technical paper. So this is a famous paper from Google. They said hidden technical debt in machine learning. So here they are showing you a machine learning, scalable machine learning system. And where's the actual machine learning? The actual machine learning, right? It's right there, the center, right? This tiny little square, right? So as you can see, when you're doing a machine learning system, there are a lot of supporting services you need around it to make it a successful machine learning system, right? So this whole process is what I call machine learning engineering. Right? So give me 1 second. All right, guys. So what is machine learning engineering? So the simplest explanation I have is process of taking machine learning models into production. So not only it involves designing models, it also involves good software engineering practices, good DevOps practices, all that. Right? So who's hiring machine learning engineers now? So I did a quick search for machine learning engineer on some of the job sites, and and a lot of listings showed up. So I can see a listing from Apple, NVIDIA, Adobe, right? And tons of startups. They're all hiring machine learning engineers. And it's pretty good too, because I wasn't used to seeing this job category maybe, I would say 3-4 years ago. This is a recent development, the machine learning engineer, because it used to be everybody was hiring data scientists. Now I'm seeing a lot of job postings for machine learning engineers, right? That was pretty cool. So now you guys are hopefully excited. Like, yes, right? This is something I'm interested in. So I sort of put a picture of the cat, see how his ears are perked up. So let's see what it takes to become a machine learning engineer. So here's a skill matrix of a machine learning engineer, right? So here you see 4 main circles: machine learning, big data, cloud, and DevOps. I'm going to go into this in detail in the next few slides. And in the meantime, guys, if you have any questions, please, I know you guys can ask the questions on the conference application. I'm keeping an eye on this. So if you have any questions, please post there, right? So, okay, so let's talk about ML, because that's a core skill for a machine learning engineer, right? What does it take for a machine learning engineer to learn ML? So a machine learning engineer, in my opinion, should have a pretty good understanding of the algorithm in both machine learning and deep learning. Now, as you know, I teach machine learning and deep learning classes, right, at companies like Cisco, Walmart, Intuit. So one of the questions I always get is, especially from software engineers, they will say, I like to learn machine learning, but I don't know advanced math. What should I do, right? I'll always tell them, look, don't worry about math so much for now. Start practicing algorithms, right? Because the algorithms and the tools have come come a long way. You can actually start using them, right, with some basic understanding of math. You don't need like really advanced calculus and advanced stats to understand the algorithms. Even though, don't get me wrong, there's a lot of math involved in both machine learning and deep learning. The algorithms actually use very advanced math. However, to use the algorithm and practice the algorithms, we don't need to go too deep into the math. So that's why I always say, tell my students, don't worry about math, just practice, right? Learn some basics of the algorithm, practice on data sets, get good at algorithms, right? Because that's a skill for machine learning engineers. A lot of the data scientists I know, they have PhDs in advanced math and advanced stats degrees, and they write algorithms. But as engineers, we are practitioners, right? We practice algorithms. We don't write algorithms, right? So that's why I always say, don't let the fact you don't know a lot of advanced math deter you. Go ahead and start learning the algorithms, right? So another question I get is, should I learn machine learning, deep learning? Which one should I learn, right? And I sort of, I really like this distinction. I thought I would share with you guys. People ask me, what's the difference between machine learning and AI? Right? And I really like this one. So, so it says, if it's written in Python, it's machine learning. If it's written in PowerPoint, that's an AI. Right? So I thought, yeah, that's a good one, right? You can appreciate the irony. So let's look at a more nuanced distinction. So here's how I look at machine learning, AI, and deep learning. So AI, I look at it as a sort of an umbrella term, right? It's basically building smarter machines. And machine learning, as you can see, is a subset of AI. It uses a lot of math and stats-based models to learn and predict. And this is where, so when people say machine learning, this is what they usually mean. Deep learning is a special subset of machine learning. It uses a technology called neural networks. So, and deep learning is pretty hot right now. There's a lot of research going on, a lot of attention being paid. So deep learning is really solving some of the hard to solve problems. For example, self-driving cars, right? Doing image recognition. These are all done by deep learning now, right? So a lot of research happening in the deep learning sector. So what I would recommend, if you are learning machine learning and deep learning, I will start by learning machine learning, right? Because you get to learn a lot of concepts, and then I would highly recommend deep learning on top of that, right? So that's how I would recommend you guys learn these two. Okay, next skill set, right? So we just looked at ML. Let's look at cloud as a skill set. So cloud, as you know, pretty much changed how we do computing. A lot of companies, even big companies, small companies, startups, everybody's pretty much moving to cloud. Because cloud, as you can imagine, is very easy to get started. You don't have to build your infrastructure, right? You can simply rent the infrastructure, or just basically swipe your credit card, and that's it, right? And you can also pay as you use. For example, you don't have to spend a lot of money upfront to buy and set up machines. Right? Just pay for your use. That's pretty convenient, and pretty much unlimited scale, right? I mean, cloud is so massive they can accommodate pretty much any demanding customer. So that's why we love to go to cloud. So imagine if a data scientist, right? So when do we go to cloud? So let's say a data scientist was working on a model, probably on their laptop, right? They have a small set of data, and they're running on small scale training, and they say, okay, this model looks promising. I want to train this model at scale. And this is where we sort of usually go to cloud in machine learning, and usually machine learning engineers will get involved at this stage. So which cloud to go? Right? If you say, okay, yes, we want to go to cloud, and you say, yeah, I want to learn cloud, which cloud should I learn? So right now we have three major cloud providers, right? Amazon, Google, and Microsoft, and they're pretty much on par services-wise. There are some services, some cloud vendors have the other vendors a little behind, but for the most part, they are very capable, and they have very good machine learning platforms as well. So I would recommend just learn a cloud system that's applicable to you and to your work. And the good thing is your skills you learn there are pretty transferable, right? So let's say you learn Amazon Cloud, and when you go to Google Cloud, the concepts are fairly similar. That's how I did, right? I started on Amazon Cloud. My company runs on Amazon Cloud. So now we use a Google Cloud quite a bit for our clients. And I can pretty much I can sort of make the mapping, right? Very easy. And also one thing I will recommend if you're new and starting out in the cloud environment, some cloud vendors give you credit when you're signing up with them. So for example, I know Google gives about $300 worth of credit. So that's a good amount of money, right? You can use that to run the cloud. So don't overthink this. Just choose a cloud vendor and start learning, and your skills are very transferable, right? Okay. So next section, big data and distributed computing. So we touched on a little bit about how training data on training large scale models. It takes a lot of compute power to do large scale training. So imagine I have a 1 gig training data on my laptop, and it takes me, let's say, an hour to do the training. So what if I have 1 terabyte? I mean, that much data probably won't even fit in my laptop, right? So at this point, we need to go to get a powerful machine, usually in the cloud. Or we can look at what we call distributed computing. So let me show you guys how distributed computing helps out here. So here I'm showing you a laptop and a cluster. So you see in the laptop, we have small amount of data, right? And when you go to cloud, you can pretty much have almost unlimited amount of data, right? And the data is actually distributed across many, many machines. So you see the blue circles, right? So data is distributed. Not only your data is distributed, when you process the data, your computation is also distributed. Right? So we are doing parallel computation. So my computation is happening on multiple machines. See, that's the orange circles, right? So there are software programs that will do this for you. For example, Apache Spark, right? It's a very popular open source platform for distributed learning. It's open source. It's supported across all the cloud platforms. And the latest version of Spark, Spark version 3 specifically, is they are geared toward machine learning. And another cool thing about Spark is actually it supports all the pretty popular machine learning algorithms. So you can pretty much start using those rather than writing them from scratch. So pretty much all the vendors support Spark. So Spark is a really good utility to learn for machine learning engineers. And also the cloud vendors, they have their own versions as well, right? So here you can see Amazon has Lambda, Google has BigQuery. This is their own implementations, right? So and you can learn those too, but remember those implementations are cloud specific, right? So okay, so excuse me. So here, let's say we train the model. My model is ready, right? We are going to deploy the model. So how do you deploy the model? So here I'm showing you a blueprint of how to deploy the model. So first thing usually we do, we package our model into a web application, right? So typically we deploy our models as web services or microservices. So first step is usually packaging of the model. And this package is called containers, and these containers are also registered in the what we call a container registry. So this is basically a cloud-specific container registry, or you can use a public one like Docker Hub as well. Then what the system will do, it will take this container image, and then as you can see, it's deploying it on multiple machines. Right? See these purple applications. These are basically images of my copies of my image, and they will start serving the model. So when a request comes in, let's say a web service request, it'll first hit the load balancer, and the load balancer will then bounce a request to one of these guys. So as you can imagine, right? For example, what happens when one of these nodes crash? Now the system has to spin up another node to compensate for that. What happens? Our requests, are increasing, right? Our service is very popular. A lot of people are using it, so our requests are going up. How do we handle them? So we need to spin up additional nodes to handle those requests. And if you think about this, this is fairly large undertaking, right? Kind of doing all this. Luckily for us, there's a software that does it. It's called Kubernetes. And this brings me to my last skill set, which is DevOps, right? So DevOps, basically, again, DevOps is a huge topic. Here I'm looking at DevOps as more looking at deploying applications and monitoring them. Because at the end of the day, right, your machine learning models and application serving requests. And you may have probably heard about these names, for example, Docker, right? Kubernetes, right? These are tools that DevOps use. So what is Docker? Docker is basically a packaging mechanism, right? It's like a container format where you package up. Like imagine like you're creating a zip file, right? With all the software you need, right? But in Docker, you're actually creating a runnable container, which you can be deployed on, on Linux or Mac or Windows. Pretty convenient and very lightweight as well. Now, Kubernetes basically takes a Docker container and runs them or deploys them on the cloud. So let's say you have a Docker container like you saw before, right? Let me go back here. So let's say you put a container and then you say, okay, I want to have 4 copies of this container running, right? Kubernetes will run this for you. And for example, if one of the machines dies, it'll start up another one. So when you say, since you said 4, Kubernetes will always make sure there's 4 copies running. So that's Kubernetes' job. So Kubernetes is pretty popular. It's introduced by Google, and now it's open source. A lot of DevOps use this, and pretty much all the cloud vendors support Kubernetes. Right? So it's such an important part of cloud system. And then I have another one called Kubeflow. So Kubeflow is basically Kubernetes optimized for machine learning, right? So again, I would definitely recommend you guys get familiar with these technologies as well. So basically, these are used in the later stages of basically deploying and monitoring the models. Okay, so I talked about quite a few skills, right? So how do we go about learning these skills? And here's a quick path I put together. I call it machine learning engineer learning path, right? It's a kind of a mouthful. So, so when you first start, I always recommend people to learn Python. So when someone comes to me and say, I want to learn machine learning, should I go start some math? Should I go take some math classes? I always say, no, actually you should take Python first, right? So Python has become de facto language for machine learning and deep learning. So I will highly, highly recommend picking up some Python. Even if you end up not using Python for machine learning, you may end up using it for scripting, system programming, things like that, right? So Python is a very good language to pick up. And there are tons of open source utilities that you have you can learn Python from. And in my machine learning guidebook, I actually give you a list of a few guidebooks, right? You can check it out. So that's the first step. And then I would recommend machine learning and then deep learning, right? Because deep learning kind of builds on a lot of the machine learning concepts. So knowing some machine learning, being comfortable in machine learning really will help you out learning deep learning. And then DevOps and cloud. So, and this is a flexible program, again, you can pick and choose how you want to learn this. For example, let's say you know cloud already, right? So then you can focus on learning the other components. Or let's say you're already a Python programmer, or let's say you're already a machine learning data scientist, right? So you can sort of learn the other, right? And recently somebody told me this big company, they said they have about 50 data scientists, and they have about only 30 machine learning engineers. So they are really looking to double the size of machine learning engineers, right? Because machine learning engineers are the ones that are supporting data scientists, right? So there's going to be a huge demand, right? Again, like I said, as you can imagine, a good machine learning engineer knows a lot of technologies, and these people are very hard to come by, right? Because you kind of need all these technologies to basically be a successful ML engineer. So right, so um, all right, guys. So again, here are some resources. You can check out the link. Again, I put this link up here. So tinyurl.com, MLng, right? So there's a link for my guided machine learning path as well. So let me quickly show you guys what I have there, right? In the guided machine learning, I'm sort of putting it together just so if you, let's say you want to learn machine learning on your own. I did machine learning. I learned machine learning on my own, right? I was self-learned machine learning. And I did, what everyone does, right? I did read a lot of books, blogs, watch a lot of videos. But now when I think back, I will do things a little differently, more efficiently, right? So there are books I read, they were like, it's okay, right? I mean, I don't really pick up anything from it. There are books I read, they were like, oh man, I wish I read this book 6 months ago, right? So what I've done is I sort of put together a guide of how you guys can go about learning machine learning in a very focused and very kind of efficient manner, right? So for example, right, here, look at Python section, right? I'm sort of giving you guys, okay, for example, okay, here's how you do basics of Python, right? Here's how you do like things like pandas and numpy. So for example, if you look at say pandas section, right? I'm giving you very simple reading, saying, so I don't say go read this book. I always say go read chapter 3 of this book, right? So it's very focused because we all have limited time these days. So I want to make sure the guide is useful. Anyway, check it out. And also after you guys are done, we have like a little checklist. So I can say okay, some exercises you can practice what you learned, right? So that's how it's written because again, this is from my experience. So like I said, I kind of did something right, did something wrong. So hopefully this is useful to somebody, right? So take a look at this, and you can always shoot me an email if you have any questions or comments on this one, right? So that's that. So that's guided machine learning. And also in the tiny URL page, I have a link. You can sign up. If you're interested in the weekly classes, you can sign up. And also you can sign up for the ML classes that's upcoming, right? So very good. And I have a couple more slides. I'm going to zip through those. Right, and here are some of the books I highly recommend. So these are, as you can see, right, these are not about machine learning. These are about, say, like doing data science on AWS, right? Doing, practical deep learning on the cloud. So these are books about how to do these things in the cloud, right? So they teach a behavioral cloud as well. One of the authors, Chris Freckley, actually he's speaking in this conference. So Chris is a very friendly and very smart guy. I will definitely check out his talk, right? So let's see. All right, that's it. So we have plenty of time if you have any questions. Again, here's my email. Here's a link if you have any questions. Let me see if I have any questions here. Right, so the question was, when the ML classes start? I'm expecting in about a month or so. I'm still kind of putting together the curriculum. So please sign in, and then you'll get an email when the class kicks off, right? So usually we do like a weekly series. Um, 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 I'll give you a lot of reading materials, and we meet weekly to discuss and review your work, things like that. Yeah. Good, guys. So that's it from me. So any questions? I'm happy to take any questions. All right, Nilesh, I think I'm looking at the viewer question here. Very good. Oh, another question I get is, would you recommend any online courses, right? So there are tons of online courses on both machine learning and deep learning. You can choose one that applies to you guys. I mean, there's like Coursera, right? Udemy, there are a lot of online content. I personally found, I like books better rather than watching videos. So I kind of learn quite a bit from the books as well. So I sort of given you guys some books as a guide. So here we go to the guide. They have a section on the books, the recommended books. Here we go, right? So a lot of the books here are free and open, right? So you can write, for example, um, Python Data Science Handbook, really wonderful book, and it's free, right? So you can read it online, and also like ThinkStat. So these are free books, and some books, you pay money, but they are worth it in my opinion, right? So I've given you guys plenty of books for you guys to start from. What I recommend is, and here's what I recommend, right? And this is something I learned the hard way too. There are tons of books, right? But what you need is sort of a study plan. So you'll say, I'm going to learn this, like step by step. Because there's no point in going and reading like a 600-page book, and that'll take you whatever 2 months or whatever, right? So you kind of plan your study and learn what you need. Yeah. So that's what hopefully this guide will help you guys out. Yeah. All right, guys. And PyTorch was TensorFlow. Um, so right now, this I'm guessing you're asking about this the guided machine learning. This guided machine learning, we are looking at machine learning, and this may expand into deep learning soon. So right now we are about halfway through this program, right? So you can sort of see here, right? We're doing like classifications at the moment, right? So this is classic machine learning, and I have plans to kind of do the same thing for deep learning as well, right? So definitely we do deep learning. For the ML Eng class, I'm still contemplating if I should cover deep learning because um, the machine learning engineering part is mostly about deploying machine learning models, right? So we'll do a basic coverage of deep learning algorithms, but we won't go too deep into this because that's not the scope. But we'll do enough so you understand sort of the basics of the algorithms and understand the mechanics, so we become productive. Yeah, yeah, good question. Thank you. Yeah. So again, I'm sort of still kind of I'm still getting requirements and still putting a curriculum together. So please email me, contact me, right? My email is over there. If you have any questions or comments, I'll definitely love to hear from you. All right, guys. Anything else?
Have
Very good.
2 more minutes. I
Oh,
guess we'll just wait for a couple of minutes to see if people have some more questions
yep.
and then close.
Sounds good to me. All right. So the way, excuse me, the way you ask the question is not using Zoom, right? You had to ask questions on the
On the
WOA
Wova
app.
app. Yes.
Exactly.
Yeah.
Right. So please, I know you guys all have access to that. So you should log in and you should see you'll see the session and then kind of click on the session and there's a button to ask questions, right? And in case you couldn't if that's not working for you, no worries. Here's my email, right? You can always shoot me an email, and also I have the same information on the right on the link as well, right? So yes, and the slides are available here as well. So very good.
Okay, since I don't see any more questions on Wova, let me ask a question, Suji. Like, what kind of projects can one, as a part of this course which you're putting together, what kind of projects will the student be actually working on?
Great question. So machine learning, I always say about machine learning is practice, 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 right? I could I could read books, I could watch videos, but at least for me, only when I start writing code and start practicing, only then can things started making sense to me. I had people in my class who would say, hey, I attended this, I watched a bunch of videos on Coursera, but I still don't have a good grasp on machine learning, right? So practice. So one thing we will do, and I'm in the process of doing this. So towards the end of this guide, again, it's not complete yet. I'll be only about halfway through. It's kind of work in progress. What I would do is I'm gonna add some sample projects. So what it include is like you'll select a data set. I will give you some suggestions as well, and then basically do like an end-to-end deployment, right? Kind of building a model, evaluating a model, and then deploying the model in the cloud, things like that, right? So yeah, so we will have some hands-on projects for you guys because yeah, that's very important, right? Because learning algorithms is one thing, but kind of using them and applying them on a project is another thing, right? That takes like a next leap. Yeah, sorry, yeah, it'll definitely be in the guidebook. Yeah, that's a great question. Thank you. And
Great. We also have one other good question on the on the
um,
Wova. Where do data engineers fit in?
That's a great question. Thank you. Yep. So I'm glad you asked this question, right? So what's happening is, right? Let me bring back my skill matrix. Um, Sorry, system's looking slow. My computer's being a little slow. Come on, come on, come on. There you go, right? So what's happening is, sort of my personal journey is I started with big data, right? This is about 10 years ago. I am what you call a data engineer, right? I work with Hadoop, I work with Spark, things like Cassandra, Kafka, all this big data stuff, right? And also, I learned cloud because a lot of our deployments in the cloud. So what's happening is now a lot of the data engineers are turning into machine learning engineers. Pretty natural transition, if you ask me, right? Because data engineers, we know a lot of these technologies already, right? For example, I know how to do in cloud, I know how to do big data, right? I know how to stand up a Spark cluster. So basically for me, I knew this already. I knew big data and cloud already. So I had to go learn machine learning. And I sort of picked up some DevOps, kind of, right? Kind of as part of the work. Yeah. So data engineers actually make perfect machine learning engineers. Just so focus on learning some machine learning algorithms, and and you are good to go. Right? So right now, that's a new job classification. Just like data engineers was a new classification like 5 years ago, right? Now ML engineers is a new job classification I'm saying. Yeah. So if you're a data engineer, I think you already have a head start. Yeah. That's very good. That's a really great question. Yeah. All right, guys. So let's see how are we doing on time, Nilesh? Are we good?
We 3 more minutes.
Okay. Yeah.
I
So
don't
I
any.
have all the time. So I want to make sure you guys have any question. Let me put the let me put the link back up. So um, all right. So here's a link for you guys to find me. My computer's really being really slow. So
Hey,
Oh,
Sujee.
yes, go ahead, please.
Hey, this is Cassidy, the co-host. Someone on chat asked about what do you think about Google Auto ML?
Sorry, auto ML. Yeah. So here's okay. That's a great question. It's called auto ML, right? So let me put this here, right? So actually, right? It's called auto ML from Google, right? So the idea there is, right? What Google is trying to do is they're trying to kind of automate as much of this model building process. So imagine a lot of the time when data scientists spin it. So if you look at the right, if you look at um, the model building exercise, a lot of the time is spent in basically tweaking the model, right? So let me kind of show you guys this. All right. Right. So there's a lot of time being spent on building the model, testing the model, right? So for example, I built a model, I test the model, it's only about 60% accurate. Okay, so we go back and say, okay, you know what, I need to do something. So we go fine tune the model, and now we went from 60% to 75%, right? Right. So a lot of the time is being spent on this one. What AutoML is trying to do is basically kind of, skipping this step. Or not skipping, basically they're kind of doing, they will do this for you. So you give the data, right? You say, here's my data, and do whatever you need to do, come back with the best model you can, right? So that's what they do. So AutoML basically what it does, like one of the features they do is like you start with the data and you specify some, some basic parameters, and they will go try a bunch of models and they will pick the best model for you guys. So they're kind of automating some of this, right? Some of this kind of, repetitive work where you sort of, try to tune some knobs, tuning and all the stuff, they will do it for you. So the idea that they're finding the idea is like, they actually have what I call super models, right? That are writing the other models. So they have a super model that understand machine learning algorithm. So that model is now training new models for you, for your data. Kind of like robots building robots, right? so that's the idea, right? So I mean, yeah, and I think it's a very valid, and we will see more and more of this we will use. But still, I still recommend, right? Because when you use AutoML, you're you're kind of like a black box. You're like, hey, here's my data, kind of, do whatever you can and then come back, right? I'll still recommend you guys understand some of the basics, and then it's okay to automate it. And I think in the next few years, we'll end up using something more like AutoML more and more, right? Because if they can do a better job and then come up with a really good model, why not, right? But still, I want you to know a little bit more, right? Exactly, yeah. So yeah, definitely check it out. It's very interesting technology, but that doesn't negate what you are learning. Mhm. Because I always say, learn the fundamentals, so you understand what's going on. But then it's okay to be in the higher, kind of a high level, right? You can let the other tools do the work for you, but you got to kind of understand what's going on. Yeah. So great question.
Great. Thank you so much. We are at the end of the session. Thank you, Suji, for the great presentation. Appreciate all the attendees for joining and all the questions and the interactions during this session. Please contact Suji if you have further questions regarding this topic. You can provide your comments and feedback to us or the organizers on the community board, or start a discussion there to connect with others in the DataCon LA 2020 community. Thank you for joining today's presentation. I hope you have gained some useful insights from this session. Have a wonderful day, and thanks again for being a part of this year's DataCon LA.
Thank you, guys. I really appreciate it. Thank you so much. And thank you, guys, for hosting.